Alright, let me go over the check-in here. This one asks, how many meters would an object go if it began at 5 meters per second, ended at 12 meters per second, and it took 10 seconds to do that? So remember, whichever variable it doesn't mention is the one that the formula can't mention. So if the variables don't mention it, your formula can't mention it, and that's how you pick a formula. So y'all cover your noses. There, I see like 3 noses. 4, 2. Tatum, cover your nose.
It is covered.
No, you're gonna cover it all the way. Alright. So it asks how many meters. So it mentions distance. It says it began at 5 meters per second, because it's meters per second. That's velocity. And it says began, so that's initial velocity. This one ended at 12 meters per second, so because it says ended in meters per second, it's final velocity. And it took 10 seconds, so that's time. So it got distance, initial velocity, final velocity, and time. This one did not mention acceleration. So if you look at your formulas, I guess you got formulas here and formulas here. The one that does not mention acceleration, okay, this one doesn't either, but out of these are the ones that mention final and initial velocity. Since this one has final and initial velocity, this one doesn't apply since it's just velocity. So the one that doesn't mention acceleration is this d equals 1, or this d equals 1, they're the same. Just to refresh your memories about how to pick a formula. So I'm going to let y'all finish the thing from yesterday. This will also help y'all get started on the one that posted today. The one that posted today will be due tomorrow. So we'll have half the day to finish this one and half today to start the other one, and then we'll finish the other one tomorrow since these are taking a while. If only because this video was so long yesterday. Anyway, are y'all looking? I'm just going to refresh you about what I did. The blue marker here, here. Those are all the things that we knew, and they're the things that the question told us. So these 3, remember, you can always write 0, 9.81, 0 in every set of boxes you write, in every chart you make. And you should make a chart for every question that you do. Whether you're drawing it on a drawing app on your phone, or you're drawing it on paper, or if you're putting it in a spreadsheet, whatever. So it told us the marble was launched at an angle of 10 degrees. That goes in horizontal angle. We're not going to fill out the vertical angle box. Remember all these, this is the X row. Everything here is horizontal. And this is the Y row. Like the Y-axis is vertical, so everything here is vertical. It says its total flight lasted 0.6 seconds. Remember, its total flight, boom. Its total flight is from here all the way to there. That's the horizontal time, because the vertical stuff only worries about the fall from here. It starts at 0 and it falls down and goes fast. That's why we've got 0 there in the vertical row. So this vertical row is just the second half. The total flight is the whole thing, and that's the horizontal part. So I put 0.6 for horizontal, and because the Y part is just the second half, it's 0.3, just half of that for Y. And it landed 10 meters away from its launch point horizontally. So I put a 10 right there. That's my horizontal distance. See? Horizontal distance. So the first question asked me to use horizontal values to calculate horizontal velocity. And my horizontal values so far were acceleration was 0, time was 0.6, and distance was 10. So if we're just finding velocity, I use my v equals d over t, plugged in 10 divided by 0.6 for v and t, and I got 16.7. That number went in these 2 boxes. These are always the same as each other, so whenever you get whenever you get horizontal velocity, it goes in both those boxes. And then it told me to use vertical values to calculate vertical final velocity. Your assignment tells you what formula to use. On y'all's assignments, make sure you're following the directions on there. If it says round to the 10th place, round to the 10th place. If it says don't round your answer, then don't round your answer. If it says round to the 100th place, then round to the 100th place. People are having trouble submitting their forms because they're not paying close attention to those directions. All right, so it tells you what formula to use in y'all's assignment, and it says use vertical values. So I'm plugging in 0.3 and negative 9.81 for A and 0 for VI. And when I do that, I get negative 2.943. This is one that says don't round, so be careful. I'll put that right there, and I'm good with that. You see how these are color coded? This is purple, this is purple. Hopefully it's coming out on the video. Hopefully y'all can see that. And the last calculation to do is that green one there. We're going to figure it out. Use vertical values to calculate vertical distance. Because we know every single other variable, we can pick which formula to use. As long as it's got displacement in it to solve for displacement, we could use this one, which we'd have to divide at the end, or we could use this one. So this is always going to be the best one to use to solve for displacement, because it's just put it in and press enter. And when I did that, remember, I'm using vertical values because I'm solving for a vertical thing. When I plugged those things in, it gave me that negative 0.44, and that's what I put there. And then I'll show y'all me working this out here. So that negative 2.943 is what I got for the vertical final velocity. That would be way over here. It'd be going negative 2.943 at the very end. That would mean that it was launched up at positive 2.943. And I'm trying to find this velocity it was launched at this angle. So I'm using this for my vertical initial velocity. And my horizontal velocity I got in that table was 16.7. And then I labeled the sides of my triangle. This is the opposite side, this is the adjacent side. I put the angle in there that it told me, 10 degrees. And it asked me to find that angled velocity. So I'm going to use the adjacent side. It doesn't matter which side you use. You could pick this side to find this side. O and H would mean you'd use sine. I'm going to use this 16.7 to find the hypotenuse. So I'm using A to find H with SOHCAHTOA. Using A to find H means that I'll use cosine since A and H go with C over here. So I wrote my formula and I plugged in my angle for theta was 10. My adjacent side was 16.7. And now I need to solve it. Remember when what you're looking for is in the denominator here, like hypotenuse is? You've got to get it out of there. It just makes it too difficult. So it says divided by hypotenuse. I'll multiply both sides by hypotenuse to get that out of there. And those cancel. So now I've got hypotenuse times cosine of 10 equals 16.7. Now that those canceled, that's what I got. And I'm almost done. I want it to say hypotenuse equals, like it does down there. Right now, it's got that cosine of 10 on this side. I just want it to say hypotenuse, so I've got to make that cancel. Since it says hypotenuse times cosine of 10, I'll divide both sides by cosine of 10. Those cancel now, so now I've got hypotenuse equals 16.7 divided by cosine of 10. And if I do that in the calculator, I just did this. Do I really not remember what it is? I got 16.96. And because these two sides are meters per second, this side has to be meters per second too. So I put meters per second. And there you go. That's what it's asking you to do. Just to refresh you from yesterday. Please try to finish the thing from yesterday here. Make sure you make a table like it says.